Okay, so this is G. Akhilandeshwari, Assistant Professor, Department of ECE from St. Joseph Institute of Technology. Today in my lecture I am going to deliver about IP. So IP means this, IP stands for Internet Protocol. If you have taken any networking related to any networking aspects, we can see this IP plays a major role, and we can see that this networking basically follows the specifications which is given in OSI model. So OSI model, it is an open system interconnection model. It is like a reference model whenever we try to transmit a data from a source to destination, and we have to follow the specifications which is given by this OSI model. So in this OSI model, we have it is like a protocol. It is like a protocol layering. Otherwise, we can say it is a layering architecture. It consists of 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this networking is a very big task. I can say networking. Suppose if I am sending a mail from my laptop to my friend, it means that it is connected to the Google server which is in US. So we are trying to make, trying to communicate with over a very big infrastructure. In order to achieve this objective, so this OSI model, it is saying we have to divide the big task into many small tasks. So that is the concept behind this protocol layering. So that is why here this networking, it is divided into 7 layers, which varies from the physical layer to the application layer. So in that, the network layers, each and every layer it is having its own function. So in that network layer, we have a protocol called Internet Protocol. So that is called IP. Like that, in each and every layer we can see that there are different protocols. For example, if I have taken a transport layer, we can see there are 2 protocols, TCP and UDP. So in this IP, we can see that there are 2 versions. One is IPv4 and IPv6. Okay. So first we will see what is called this IP, why this IP is needed, and what is the difference between this IPv6 and IPv4. How far this IPv6 is advantageous than IPv4. So as I said, whenever networking comes into the picture, so we are trying to transmit a packet from a source to the destination, so over a distance. Okay, so we can see that it is a very far distance, and so the source and destination, in between we can see we have several intermediate nodes. So these intermediate nodes are like routers, switches, and gateway. Like that, we will be dealing with so many intermediate nodes. There could be many servers. So in such a way only we can able to reach this destination. But the challenge here is you have to identify the destination network in which your destination host is residing. Right? So for doing this task, we go with the network layer basically. This network layer, it helps in configuring this IP address. So IP address, it is a 32-bit address. It is a 32-bit address. So we usually follow this IPv4 version. In IPv4 version, it is 32-bit, whereas in case of IPv6, it is of 128-bit. Okay. So we will discuss why this V6 is needed and what is the drawback with the V4 later. First we see what is this IP addressing. If I have taken a network, it is a very big infrastructure. Like I can say millions or trillions of hosts are interconnected together. Okay, we can say like entire globe is in my hand. Like so many hosts are connected in that network. So in such a network infrastructure, I have to identify each and every host which is connected to this internet infrastructure. So for example, if we have taken a student in a university, each and every student is assigned with a unique register number, so that we can able to identify that student, right? Similarly, in a network infrastructure, I have to identify which is the host, and okay, this host, it corresponds to this IPv4 address. This IPv4 address is a 32-bit unique address, which is a unique address means that it conforms to the identity of every host which is connected in the network. Only if this IP address is configured, then only this host it can able to access the internet. Okay. Now, IPv4 and IPv6. Actually, it doesn't mean like there are only two versions. IP version 4, Internet Protocol version 4, Internet Protocol version 6. It doesn't mean like there are only two versions. Actually, IP version 1 has came, version 2 has came. But only this V4 became very popular. But the thing is that with the V4, it is not able to sufficient to address the number of devices we have in a network, because nowadays we can see that everyone is generating data. If I have taken this second, so many are generating data. So there are so many devices which are being keep on added to the network. So day by day the number of users are increasing. So if I have taken this IPv4, it is a 32-bit address. So which means that I can able to form 2 power 32 memory locations. Okay, so those many devices, that's 2 power 32 number of combinations. So those many number of devices I can able to assign address. Okay, but in order to meet with the multimedia, like nowadays we can see that we go with the multimedia, we go with the VoIP, we go with video streaming. So the day by day the number of devices which is being connected into the internet is increasing, exponentially increasing. So for that purpose only this V6 has evolved. This V6, it is basically a 128-bit address. Now you can imagine if you put 2 power 128, so it becomes a very big number. Okay, so those much enormous amount of devices it can be connected. So I can say that if I have taken a globe, okay, so each and every grain of a sand in the globe I can able to address. So this is more than sufficient to meet the demand we have right now with the networks with more number of users. So that is why we go with the IPv6. Not only that, IPv6 it is a 128-bit address, so maximum it can support 2 power 128 possible combinations. Those many devices can be connected. Not only that, but if you just compare this version 4 format with the version 6, you can see this version 6 is simplified than that of this version 4. Okay, before that I have to clarify what is meant by this header. So basically header means if I have taken this layering concept. So at each and every layer we take the data and we will do some process and it is given to the next layer. That is, if I have taken a physical layer, so I am going to do some processing with the data. So what I am going to do means basically it is an encapsulation process. I will take my data and I will be adding a header and it is sent to the next layer, that is data link layer. So in data link layer again what it will do, it takes this whole data and it is going to add its own header to it. Then it is given to the network layer. So this process is called encapsulation. So in that this part actually it is nothing but a header. So if we have taken any layer, it contains the two parts. One is the payload part. The payload which is nothing but the user information which we are trying to communicate. Okay. But whenever we are trying to communicate over longer distance, like throughout this 7 continents, we are trying to communicate from one continent to another continent. Okay, in order to the successful delivery of my data, so my data has to arrive to the destination successfully. So what I have to do, I have to follow this encapsulation process which is going to happen at each and every layer. So at each and every layer I am going to add some header. So it is similar to like when we post a letter, okay. We not only post the letter, what we will do, so we will write the content, then we will wrap it in a case and it is sent. Then we will write the to address and from address so that the postman he can able to understand to whom he has to deliver that that letter, right? Similar to that, so at each and every layer we are going to take the whole data and we are going to add a header to it. It is like a wrapping process. We used to say this networking, looks like the layered architecture, it looks like an onion structure. If you peel off one layer, then you can find there is another layer. If you peel off the second layer, then you can see there is another one inner layer. So this is the basic concept with the layering architecture. So from that we can understand that it contains two parts. One is the payload part which we are trying to transmit, that is the data which we are trying to transmit to the destination. So in order to deliver that information successfully to the destination, we are going to prepare the header to it. Okay, so this header, it is going to contain some details about the destination. Who is the source address and who is the destination address. Okay, but not only that one. Okay, not only the source address and destination address. We used to say source address SC, destination address B. Not that only is sufficient. So we might be in need of so many details. It has to be presented in this header. Okay, so if I zoom this header, okay, you can see, if I zoom the header format of IPv6, so you can find there are 8 fields sitting in this header. Similarly, if I zoom IPv4 header format, so there are 14 fields which are sitting in the header. Okay, so now it is very important for us to give a description for each and every field which is present in the header. So what is the information it is going to share? So also we can make a comparison between this IPv4 and IPv6. So how this IPv6 is more simplified, what are all the fields which has been removed, what are all the fields which are going to provide new features. So everything we are going to discuss. Now the first field basically it is a version. So version means if it is a v6, it contains 6 here. Okay. Then second thing is the traffic class. So basically this traffic class, what is the data I am going to transmit in the pipeline. So the traffic is nothing but the data or the packet which I am going to transmit. The very important thing is the flow label. So because you can see in IPv4 address, we don't have this field. This is a new field which is added in IPv6. This flow label actually, this label it is being used by the router. Basically in networking, when we have taken this networking, this router it plays a major role. Actually this router only can able to route the packet to the destination, because if I have taken internet, it is a very big infrastructure. So there are so many different types of networks are connected together. Okay, so like I have to reach the destination network. So then only what I can able to do, I can deliver my packet to the destination host, which is present in the destination network. Okay, so this router it is going to play a major role. What a router will do means, just imagine the router is a device which is having multiple hands. So in the pipeline, like you will be keep on sending data. Okay, whenever a packet comes, this router it receives it. Okay, then what it will do, it will just remove the header, then it will see what is the destination to whom it has to deliver. Then you can see that, like if you imagine this infrastructure, internet infrastructure, so you have to imagine it like there are different types of networks are there, different routers are there, different servers are there. Okay, so in that it has to see which path it has to forward that packet. Basically this routing means it is like a packet forwarding. So via which door it has to forward that packet so that it can deliver the destination. So this flow label basically it helps this router to identify what type of data it is receiving. Because this router it cannot like keep on inspecting the header thoroughly, like it is taking much of time to identify what type of data it is, whether it is a video streaming or whether it is a VoIP, voice over internet protocol. So it has to give some priority to that, because these are all like real-time streaming. If it is happening, it has to give a priority. So priority means it should not like the router keep on inspecting what type of data it is. Okay, so this label it helps to identify that so this particular packet it is having same type of data and which is having a priority. So without inspecting much, we have to forward that. Okay, to identify that only this flow label is used. The payload length basically here is the length of the data, user data, and next header. Only in case of IPv6 we can see that this header we can able to go for extension header. So extension header means suppose if this header is not sufficient. So basically we have a 40 bytes of header. So if this is not sufficient, then I can go for the extension. Okay, that is feasible with the next header. And off limit basically is which because my packet is should not held in a loop. Okay, so if I am transmitting from this source to this destination. Okay, suppose if I have three routers which are present, then while transmitting I will be setting the hop limit. Okay, so the hop limit, like so initially this hop limit will be 4. So once it arrives at this router, what I will do means it will decrement. So now the hop limit value will be 3. When it arrives here, it will be again decremented by 1. The hop limit value will be 2. When it arrives it here, again it will be decremented. The hop limit value will be 1. So once the hop limit it comes to 0, so it means that no more further forwarding, it will be given to the destination. In such a way, we are going to avoid the looping. Sometimes what happens means this packet will be like keep on traveling in a loop, and it will not be delivered to the destination. To avoid that only we have this field called hop limit. So this hop limit in IPv4 we have it like a TTL. Basically it's a TTL. Instead of this hop limit we will be having like a TTL. So TTL will be 4 here. So when TTL becomes 0, no more forwarding, it will be delivered to the destination. So these two are the very, very significant part. As we know, whenever we transmit some data, we should know from whom the data is being transmitted, to whom it has to deliver the data. So that is very, very important. So in case of IPv6, we go with a 128-bit destination address and 128-bit source address. Okay. Now, coming to this IPv4 header format, you can see that it contains 14 fields, whereas this V6 structure, it looks much simplified. It contains only the fields which are all needed. Okay, there is no repetition. Okay, because here we can see there are some of the fields which are like I am repeating my data. Okay, but here it contains only the fields which are needed. The fields which are all not needed, it is being removed. Okay. So now with the IPv4 architecture, we have taken the 14 fields. Let me give the description of each field I have. The first one is a version, so we will be having a 4. And again here header length. Okay, the header length means what is the length of the header. In case of V6, we have like header length is fixed, but here the header length is variable. So that is the advantage of IPv6. Then type of service. So here we have it like a traffic class. Instead of here we have a type of service. Also there is another field called total length. So total length means what is the length of the header and length of the payload. So that's why I said header length is also there, and total length, like that it is having two different fields. Then these three fields are identification, flags and fragment offset. Basically this is for fragmentation. So whenever you transmit a large datagram, okay, what happens is that we will try to divide that into many smaller fragments, okay, and each small fragment will be sent over the network. So finally at the destination we are going to combine these fragments together to get my original message back. So these three fields are used for the fragmentation purpose: identification, flags and fragment offset. And as I said, instead of hop limit we have this TTL, time to live, and we have a protocol and header checksum. So here checksum basically it is a very popular technique when it comes for error control. Error control means error detection and error correction. So because once I transmit my data, I have to ensure my data has been received as I have transmitted. So that integrity is not changed. Whatever I transmitted only I have, it is received by the receiver. There is no changes happened during when it is sent over the channel. Okay, because in channel lot of deviations can happen, right? So there might be attenuation or maybe due to fading effect. So something can happen to my receiving data, the received signal strength. So I have to check that at receiver I have received my data as it is transmitted. So for that purpose only we have this checksum. So the header checksum, which means that it is only for the header, not for the payload. So this checksum basically what it will do error detection and error correction. And here they have given like options just padding. So padding basically we can understand like suppose if this is 32 bit, okay, but if I have only this 30 bits, then 2 bits is not available, right? But in network, the very important thing is that whatever frame format we are defining, it should be transmitted to that specifications only. Suppose instead of 32 bits, if I send it like a 30 bits, then it will treat that packet as an error. Okay. So in order to that, we will be adding extra bits to make it this 32 bit. So this is the process called padding. Basically, these options it is given for the developers. Okay. Suppose I have these 13 fields. Okay. So if I have to add any more fields, okay, the developer thinks like some fields it is needed, okay, to communicate my packet successfully to the destination, then the developers they can go with the field called options. So by comparing this V4 and V6 architecture, so we can see that V6 basically it supports more number of devices can be connected, because 2 power 128 2 power 128, so it is a very big number. Okay, those many devices can be connected, can be assigned IP addresses with the help of IPv6. Then we can see that the architecture is very simplified, because when we go with the higher versions, the one thing we see is whether the architecture is simplified, okay, and it contains only the essential fields. So all these things it conforms to this IPv6 header format. So till now we can see that IPv6 header format is used extensively. So without this IP, we cannot do anything in networking. Only with the help of IP, we can able to do IP addressing. Each and every host which is connected in network will be assigned with an IP address, so that the host can able to access the internet. The second thing is routing. So routing it helps for my information to successfully arrive at the destination. Okay. For the routing, we have different types of routing protocols. So routing is a very broader area. We can discuss more on that. So to put it in a nutshell, I can say like IPv4 is a 32-bit address, IPv6 is a 128-bit address. So basically this will be represented by dotted decimal notation. We used to write an IPv4 address like 192.168.3.2, whereas in case of IPv6 it will be like an alphanumeric hexadecimal notation. It will be represented and it will be separated by colon. Okay. So I hope now you can able to differentiate between IPv6 header format and IPv4 header format, and why this IPv6 is more advantageous than IPv4 header format. Thank you.
If we have taken a network layer, one of the important function is a routing. So what do you mean by routing? Routing means you have to, if I have a source and destination, if I am transmitting a packet from source to the destination, then in between many intermediate nodes are present. These intermediate nodes, nothing but routers may present in between. So if we have taken a single router, okay, it maybe keep on receiving IP packets, okay, multiple incoming IP packets. So what it will do, it will take the IP packets and it will do the decapsulation. So decapsulation means it will remove the header and it will see who is the source and who is the destination, okay, from whom it is getting a data and to whom it has to deliver the data. So what it will do, it will see to the destination address and it will forward the packets accordingly so that it can reach the destination network. Okay, so once it reaches the destination network, like till it reaches the destination network, it will keep on forwarding the packet. Once it reaches the destination network, it will identify which is the destination host which is present in a destination network. Then it will deliver the packet to that host. Okay, so this is a router. Router means it is routing the packets and it will forward the packets like hop by hop delivery until it reaches the destination. So basically this in network layer we need to have a routing protocol. So because nowadays we are not dealing with anything manual, okay, everything is automated, right? So in network layer this routing is done by with the help of a routing protocol, okay, automatically. So the routing protocol can be categorized into two different routing protocol. One is unicast routing, second one is a multicast routing. So basically unicast routing means from a single source to the single destination. Okay, that is a basic type of a routing protocol. So in that we have a two popular method, the fundamental technique, distance vector routing and link state routing. We used to say distance vector routing protocol, link state routing protocol. Okay, these two are the fundamental techniques, basic routing protocols. Also we have another one technique, it is path vector routing. Okay, so further this DV, distance vector, is a theoretical concept. The implementation of this distance vector routing protocol is nothing but a routing information protocol. Okay, similarly link state routing is a concept. Okay, the implementation of link state routing is nothing but OSPF, open shortest path first protocol. Similarly the implementation of a path vector routing is nothing but a BGP, border gateway routing protocol. Okay, so these are like from single source to single destination. If that is the application, I can go with any of this unicast routing protocol. But nowadays we can see like we will be dealing with a group of destination. Okay, maybe in internet architecture, if I have taken, so for example, consider I have millions of hosts which are connected in internet. Okay, usually internet, if we have taken the number of hosts, number of computers connected, it will be like enormous amount, right? So suppose consider I have a million or a trillion number of hosts which is connected in internet. Okay, in that I'm not going to transmit my data to all the host which is connected in internet. I will be identifying, suppose if there is a software. Okay, the software, it will provide access only to the premium customers, whoever have if it is a licensed software, what it will do, it will see whether they have paid for the premium. Okay, it will identify only the group of host, like customers, those who have purchase the premium. So we have to see the selected group of host, okay, in internet, not everyone. So that is why in network routing, network layer, the routing protocol, we have only two types. Okay, unicast and multicasting. We don't have a broadcast. So broadcast means from the same source to the multiple receivers which is present in that is, if I have taken internet, there will be millions of hosts present in internet. Okay, so broadcasting means I will be transmitting the same data to the multiple host which is presented in internet. So it is like a flooding process. So that will not be done in a network layer, it will be done in data link layer itself. Okay, so you have to very clearly understand that we have only two different types of routing protocol. One is unicast routing and multicast routing. So multicast routing is the nowadays we can see a lot of applications we are using, it is with the help of this multicast routing. So we will identify a group of receivers, that is a group of receivers present in an internet architecture. Okay, not everyone, and we will be transmitting the data only to the selected group of receivers. Okay, for example, if I open my laptop, okay, I am using a Windows operating system. Okay, you can see that it is like once if it is connected to the internet, okay, then it is automatically you can see that it is automatically updating the software packages. Okay, if there is any updation, it will do that automatically. So these and all, it will be done by the multicast routing protocol. Okay.
Okay, so to summarize this IPv6 versus IPv4 versus IPv6, we can say this IPv4 basically follows adopted decimal notation. IPv6 it uses alphanumeric hexadecimal notation separated by colon. Okay, so this is of 128 bit and this is of 32 bit. So we can see the advantage with IPv6 is if I have a 128 bit address, then maximum number of possible combinations will be 3.4. It is about 3.4 into 10 to the power of 38 addresses. Okay, so which is more than sufficient to assign addresses to the every grain in the sand of my globe. So like as even though it is exponentially increasing, okay, we cannot see like it won't exceed this limit because that many devices I can able to connect and I can able to assign IP address with the help of IPv6. Okay, but with the P4 we can see that it is limited only about 4.3 billion devices can able to be assigned IP addresses. Okay, and so this is the major reason why we are migrating from IPv4 to IPv6. And also we can see that with IPv6 we have some salient features which are not available with IPv4. Then another advantage I can point out with the IPv6 packet header format, the header length is a fixed one, it is 40 bytes. Whereas in case of IPv4, it is a variable length header. It can vary from the minimum 20 to 60 bytes. Then here, this is very important, the flow label. Okay, whenever if I am transmitting something very important, I want to assign some priority. I don't want my, so this is the router I have, right? In my network, there are many routers are present in between. Whenever this router is receiving packets, okay, this router it will explore into the header details. Suppose if it is taking much of time in processing each and every packet which is being received by this router, then we cannot say this is an efficient. So we have to speed up the processing. So for that purpose only in IPv6 it introduced flow label. This label it is recognized by this router to identify that the data streams which is being transmitted it is of the same type, so that it won't spend much of time or it won't deep dive into the header and keep on inspecting it. So it helps to the so this one it helps the speed of the processing. So this is not available with the IPv4. Then another thing is that suppose if I think this 40 bytes header is not sufficient. Okay, so basically this is the format, right? So we have a payload, then we have a header. So if one header, this header is not sufficient, then I can extend the header. I can go for another header. Again, if it is not sufficient, I can go for another header. Okay, so this extension of header is available with this IPv6 address. So we can see that networking it plays a major networking almost in every applications. Okay, networking is being utilized. Without networking, we cannot even think, because we are saying like entire world is in my hand. So because I am being interconnected, wherever I go, I am still connected. Okay, so I am providing seamless connectivity, irrespective of at what time I am, at what speed I am traveling. Like nowadays there is a demand from the user for everything. Okay, it should be high speed. It has to provide a higher bandwidth. It has to support all type of formats. So like so in order to provide such a network infrastructure, I can say this IP is playing a major role. Without IP, we cannot handle IP addressing. That is, each and every host is given a unique identity. Each and every host which is present in network, so we need an identification that is done by this IP. Then, whenever a packet is arriving on the router it has to ensure the packet is reaching the destination. Till that, it is keep on forwarding the packet. Okay. So if router is not there, we cannot even imagine we can able to communicate from one network to another network, or we can able to visit a different network. So I can say this router is a very significant device we have in networking, which is going to help the packet to reach the destination successfully. Thank you.